first things first. All right, when you go into your Hawk system and stuff, you know, even though we just had our test, we always try to give you guys that little extra time to make sure your homework is done. So just to let you guys know, what do you guys got to do this weekend? You got quiz 10 and section 5.4 and 5.5a, okay? And hopefully you've already done it, which is awesome because that's actually what you're supposed to do before you actually take the test. So, but if you haven't and you're having some difficulty, like I said, typing in on the Hawk system, I just want to remind you guys that every Friday from 12:30 until 1:45 in Fretwell 113, we have a review session where we'll go over any kind of questions that you guys happen to have and stuff. Now, last time, Sonda's told me you guys had a lot of homework questions and stuff, which is absolutely fine. That's what it's there for. But also, we'll get you into the Hawk system because, again, people are still having some tough time typing that exact equation. One parenthesis in the wrong spot, one little spot makes the whole thing wrong, and it's a computer, so it doesn't grade whether it's almost right. It pretty much grades it right or wrong. So if you need the help, we're giving you the help with Hawk system stuff. And also remind you guys about the Math Resource Center right across the hall from the math department on the third floor of the Math Learning Center. We got open tutoring in there. So if you need some help on getting some stuff done, hey, get some help. We've got resources, but you've got to be the ones that go out there and take advantage of this stuff. All right. Well, let's move on. Last time, I just introduced the concept, but I didn't get much into it. And that concept is, here it is, chapter 6, the last chapter here, is called integration or anti-differentiation. It's the same thing. Integrals and antiderivatives is the same thing. So what we're doing is we're going in reverse. So let me give you the big idea here. So the big idea is, well, from day one in this class, after we introduced the concept of limits, was we gave you a function and we asked you what's the derivative of it. And we did a lot of, obviously, word problems and the like. You know, how do you know to take a derivative? Well, you know to take a derivative when you hear the words, calculate the rate of change or something or other. Buzzwords on taking derivative. So, you know, slope of the tangent line, take derivative. So we've given you a function and we asked you about the derivative. Now, what's going on here with integration or anti-differentiation is this. We're going to give you the derivative function and ask what is the original function f of x. That's the whole goal here. It's called anti-differentiation. Now, a symbol for this anti-differentiation, or what we call integration, is an elongated s. So here's the idea. When I integrate, that's the elongated s, of the derivative function, dx, that's going to be equal to the original function plus an arbitrary constant, plus c. And c, because we're going in reverse. So the derivative of 5 is 0. Derivative of 17 is 0. Derivative of -2 is 0. But now we're going in reverse. So what is the antiderivative of 0? Well, is it -2? It was at 17? Well, honestly, it could be any arbitrary constant. It is. That's why we always put this plus c. So here's the deal. And here's the rules you guys need to go. And I'll write this thing twice, but here's the main idea. If, remember, from day one when we took derivatives, after we did the limit stuff, we actually came up with the short method derivatives. You know, the derivative of x to the n was nx to the n minus 1. The derivative of e to the x is e to the x. The derivative natural log of x is 1 over x. You know, we had all these wonderful rules that you had to have memorized. Well, if you got rules to go from the function to the derivative, you're going to have rules to go from the derivative back to the function. And these are the rules you need to know. And there's not many of them. Okay? Because remember, we had this chain rule, quotient rule, product rule. Now, you don't have that kind of stuff for integration. What you're going to have is a technique called U substitution. And we'll get to that later. That's in section 6.2. But, so what you got basically here is memorizing the basic formulas. And here they are. Number one, when I integrate a constant, that's the integral of a constant or antiderivative of a constant, dx, that little dx stands for with respect to x, so you know what the variable is. It's going to be equal to a constant times x plus c. An example of that would be the integral of 5 with respect to x Integral of 5 dx is going to be 5x plus c. But sometimes we won't have x. We'll have a different variable, t. Fine. You know what the integral of 7 dt is going to be? Well, that dt tells me t is the variable. So the integral of 7 dt would be 7t plus c. We use arbitrary x because that's our happy world, but you can use t's or any other letters you want. Okay, that's rule number 1. Rule number 2 is this. The integral of x to the n dx. This is called the power rule. It's like with derivatives, but it's in reverse. When we took the derivative of x to the n, we stuck the n out front, x, and we subtracted 1. But now we're going in reverse, so we've got to do it opposite. So the opposite of subtracting 1 is to add 1. So the answer is going to be x to the n plus 1. Instead of sticking them out in the front, you stick them in the denominator. Divided by n plus 1 plus c. Provided n does not equal -1, this is a rule. So an example, what's the integral of x cubed dx? That's going to be equal to x to the 4 divided by 4 plus c. Add 1 over add 1. So the integral of x to the 7th dx is going to be x to the 7 plus 1, which is 8 over 8 plus c. This is your antiderivative going in reverse. The powers are getting bigger instead of getting smaller. Okay? Rule number 3 is this. The integral of x to the -1 dx. What happens when n actually equals -1? Well, that's the same thing as the integral of 1 over x, because negative exponent puts them on the bottom dx. And remember, we're going in reverse. So here's your big idea. This is my derivative. What function, when I take its derivative, is 1 over x? You got it. Natural log. Officially, we throw an absolute value around the x plus c. And this to remind you that, remember, x, you can't take the log of 0, you can't take the log of a negative number, you can only take the log of positive numbers. So we throw absolute values just to remind you of that. Okay? Rule number 4 is this. The integral of e to the x. Let's talk about that dude for a second. Integral of e to the x dx. What's the derivative of e to the x? E to the x. So therefore, what's the integral of e to the x? E to the x plus c. That's about as easy as you get it. Since e to the x is its own derivative, it's also going to be its own antiderivative or integral. Okay. A couple of other rules that you guys need to know. Number 5, the integral of a constant times a function dx. Constants get to go where? Just like with derivatives. You held them out front when you're multiplying by an x variable, and you just basically focused on the derivative. Well, same idea with antiderivative. The constant will get to go out front, and you focus on integrating the actual function. Okay? And rule number 6 is this. The integral of a function plus or minus another function. Adding or subtracting. We don't have product rules for integration. We don't have quotient rules for integration. But we do have a sum difference rule. Now, if you're adding or subtracting two functions and you're going to need to take the integral or antiderivative of it, what you do is you take the integral or antiderivative of the first guy, okay, plus or minus whatever happens to be the integral or antiderivative of the second function, dx. Okay? And then there is also one other little note, and I will put it up here. This is the idea. When I integrate the derivative, I'm going to get the original function back. Now let's use that in terms of concepts here. When I integrate the first derivative, I get the original function back. What do you think is this? If I happen to integrate the second derivative, what do you think I'm going to get back? Antiderivative of the second derivative. See, this is the antiderivative of the first derivative. Antiderivative and derivative cancel, you get the function back. What's the antiderivative of the second derivative? The first derivative. Plus c. And you can continue on with this idea. So this is, ideas. This is 1, this is 2. And there's a third one that is basically a notation. That is this. The integral of little f of x dx. Now, if you look at this little power rule, when I integrate x to the n, when you integrate x to a power, you're supposed to add 1, divide by add 1, okay? So if this was integral of x squared dx, this would be x cubed divided by 3 plus c. What happened to the power? You went from x squared to an x what? Cubed. It got bigger, right? And we're math people, so don't think too deep in how we come up with names and formulas for stuff. When you integrate a little function, f of x dx, you're going to get back, this will be equal to a big function, big f of x plus c. So they're going to see in your problems, they're going to say, given little f of x is equal to whatever, find big f of x. You're supposed to take the antiderivative of it to get big f of x from little f of x. It's just a little notation aspect here. Because when you integrate, because of that power rule, add 1 over add 1, it makes the functions bigger, so we call the bigger function big f of x, where the original function was little f of x. But the main idea is the guy you're going to be integrating is the derivative function, and when you integrate them, you'll get the original function back again. So right here, these are the rules that you need to have memorized for anti-differentiation, also known as integration. It's the same thing. There's only 6 of them, okay? Plus my little notation stuff up here. Oh, don't worry, we'll add to this list, but not much, because there's going to be a different technique. These are the ones you need to have memorized. So let's come over here to our Hawks notes and stuff like that, and let's take a look at some of the ideas that we've just written down. And I'll write these formulas down again formally in your notes here. The indefinite integral. An indefinite integral is an integral that, like we just had, this will be an integral, quote unquote, without bounds. This is your indefinite integral. It's just that elongated s. And what you're going to get is, you're going to get, when you take the antiderivative of the derivative function, you get the original function back plus c. That plus c lets you know that it's going to be an indefinite integral. So versus what we call a definite integral. A definite integral is going to have some numbers on the bounds, on the low part of the s and the upper part of the s, and they're going to mean something later on. We'll talk about that later. All right. So, basically this whole section is about rules of integration or anti-differentiation, finding the integrals. Okay? Okay, so, in words, the process of reversing differentiation is called anti-differentiation. Okay? If big F and little f are 2 functions, and big F prime of x is equal to little f of x for all x in the domain, then f is the antiderivative, is an antiderivative of little f. Remember I just talked to you about this notation of big F's and little f's? When you take the antiderivative or integral of little f, we call it big F. If big G and big F are both antiderivatives of the same function, then g of x will be equal to, big G of x will be equal to big F of x plus c. See, here's the deal. When you integrate, you can get the same function back, but you got plus c. These two guys will probably, if they're the same antiderivative of the same function, the only way they're going to happen is they may differ by a constant. You know, what's the difference between, what's the integral of x squared? It's x cubed over 3 plus c plus 5, your constant could be 5, and then integrate the other guy, it would be x cubed over 3 minus 2. They're only going to differ by a constant. Their functional part will be the same. Okay? Number 4, given f of x is any antiderivative of little f of x, the indefinite integral of f of x is symbolized by the elongated s of little f of x dx. And this is just, the dx is is just designed to let you know what the variable is. Okay? Well, it's pretty obvious. Yeah, but when you integrate a constant, integral of 5, what's the answer? Well, I don't know what it is until you tell me what the d thing is. Integral of 5 dt would be 5t. Integral of 5 dx would be 5x. Integral of 5 du would be 5u. That D thing's telling me what the variable is, because if you just got, some things without variable in it, you don't actually know what the variable is until we tell you. The indefinite integral is defined by, and here's my little notation, the integral of little f of x dx is equal to big F of x plus c. When you integrate, you make the function bigger. Where c is an arbitrary constant and is called the constant of integration. That's what that plus c thing is, the constant of integration. In the indefinite integral, the integral of f of x dx, f of x is called the integrand. These are the fancy words. That's the guy on the inside of your integral, okay? And dx is called the differential. That with respect to x, differential. All right. So, here we go. Here are my rules. What's the integral of a constant dx? K being a constant, the formula is a constant times x plus arbitrary c, that's plus c, constant of integration. The integral of x to the r is going to be x to the r plus 1 divided by r plus 1 plus c, provided r is not equal to negative 1. So we've got a special rule for that guy. The integral of 1 over x dx, what's that one equal to? Natural log absolute value of x plus c. The integral of e to the x dx is e to the x plus c. And some other rules for integration is this. The integral of a constant times f of x is equal to the constant times the integral of f of x dx. Constants get to be pulled out front. And when you integrate a function plus or minus another function dx, you get to integrate the first function, dx, plus or minus the integral of the second function, g of x, dx. So again, rewriting the rules I wrote down before. Now, with this integral of x to the r, or I call it x to the n, x to the r plus 1 over r plus 1, there's no restriction on r except it can't be negative 1. It could be fractions, they could be negative exponents, they could be a big positive whole numbers, doesn't matter. Now, here we go. Let's take a look at this video example here from Hawks TV. Find the integral of negative 5 over x plus 2x to the 3/5 minus 3e to the x dx. Okay? So again, what we want to do is get you guys to be able to do this stuff in your head, but I'm going to write this thing out in the appropriate rules to remind you of what you're supposed to do. When you integrate a bunch of func terms that are being added or subtracted, you get to integrate each one. So this would be officially equal to the integral of negative 5 over x dx plus the integral of 2x to the 3/5 dx minus the integral of 3e to the x dx. Now, second rule. When you got a constant being multiplied by a function, you can pull that constant out front. So you're trying to actually focus on the function and the rules we have memorized. So this would be equal to negative 5 times integral of 1 over x dx. I pull my constant negative 5 out front. Plus 2 times integral of x to the 3/5 dx minus, pulling the 3 out, 3 times integral of e to the x dx. And now you apply your integral rules. What was that integral of 1 over x dx that you have memorized? Natural log absolute value of x. Just to remind you about the absolute values, but you're right, it's natural log of x. We can always throw the absolute value on there to remind you. Can't take a log of a negative number. Plus 2 is a constant, holds over. What's the integral of x to the 3/5? Anytime you got x to a power, add 1 over add 1 is how you integrate. That is this rule right here, what we call b up here. Add 1 over add 1. So you've got to do math in your head here. This would be x to the, what is 3/5 plus 1? 3/5 plus 1 is 5/5. That gives you what? 8/5. X to the 8/5 divided by 8/5, right? Minus, 3 is a constant. It holds over. What's the integral of e to the x? E to the x. It's its own integral, it's its own derivative. But now, you'll notice something that I left off every time I integrate it. Every time you integrate, you get a plus c constant. But here's the deal. When I integrate this guy, you get a plus c. When I integrate this guy, you get a plus c. When I integrate this guy, you get a plus c. What's a constant plus a constant plus a constant? One big constant. So we don't put, 3 c's up here. You just put one big plus c. Because every time you integrate, you're going to get a constant integration, but you combine that, just make it one big plus c. Now, the last thing you got to do is clean it up. So we like nice, cleaned up answers. So my answer on this problem is going to be -5 times the natural log absolute value of x. This one, when you divide by a fraction, what do? You invert and multiply. Multiply by the reciprocal. So this will actually flop up on top and become 5/8. And 2 times 5/8, well, 2 goes into 8 4 times. You end up getting plus, when you clean it up, 5/4 x to the 8/5. And again, it's 5/8 times 2. 2 goes into 8 4 times. That's where I'm getting the 5/4 out front end. Minus 3 e to the x plus c. And that is my solution. Does that make sense? So, this, and if you want to check this, knock yourself out. You know how you check this thing? You see this function right here? That's going to be that big f of x. If you take the derivative of this guy, you know what you're going to get? What's inside that integral dx? Derivative of -5 natural log of x is going to be -5 times 1 over x. Derivative of 5/4 x to the 5/8, you bring down the, x to the 8/5, excuse me. You bring down the 8/5 and subtract 1, and 8/5 times that 5/4 ends up giving you 2, x to the subtract 1, which gives you 3/5, minus 3, derivative of e to the x is e to the x. I get the same function back. And derivative of constant is 0, so the plus c doesn't show up. So you can always double check yourself. So let's see if you guys have these formulas memorized yet. All right. So the first one, what's the integral of -8 dx? And I'm going to pull my little rules that I made up just a few seconds ago. When you integrate a constant with respect to x, you get a constant times that x plus c. So what's the integral of -8 dx? -8x plus c. What's the integral of -3x to -2 plus 3? Well, I'm not going to do this but one more time. When you integrate, things are being added, subtracted, you're going to integrate each one. And constants get to pull out front. So I'm going to start speeding up the process here. This would be -3 times the integral of x to the -2 dx plus 3, the integral of 3 with respect to x dx. Just integrate each one. This one, I pulled the constant out front. So this is -3. What's the integral x to the -2? Integral x to a power, most important rule. Add 1 over add 1. -2 plus 1 is x to the -1 over -1. Plus the integral of a constant with respect to x would be the constant times x. That would be 3x. And then one big plus c. But the last thing you're going to do with this mess is clean them up. What is -3 divided by -1? 3. What's x to the -1? Negative exponents go back where they came from, which is on the bottom and becomes +1 plus 3x plus c. There's your answer. The next guy, the integral of -5x to the 4/5 minus 6. Well, again, it's two terms being, in this case, subtracted. So I'm going to integrate the first guy minus integrate the second guy. And I'm going to pull my constant out front, so it'll be -5, the integral of x to the 4/5 dx minus the integral of 6 dx. -5 is a constant, it holds over. Integral of x to the 4/5. I've got to be able to do math in your head. Add 1 over add 1. 4/5 plus 1 is 9/5. So this would be x to the 9/5 divided by 9/5, whatever gets to be the power gets to go in the denominator, x to the n plus 1 over n plus 1, minus, what's the integral of 6 with respect to x? 6x, and one big plus c. And what's the last thing you got to do? Clean them up. So I'm going to invert and multiply. So this ends up being 5 over 9 times negative 5x to the 9/5 minus 6x plus c. And then the last thing. Clean it up. 5 times a negative 5 is actually a negative 25 over 9, x to the 9/5 minus 6x plus c, and there's my resultant. Does that make sense? Well, if you've learned anything in this class, based on the last test and the test before it and the test before it, you have something called John's fundamental rule of calculus. John's fundamental rule of calculus is very simple. It is better to clean up your algebra before your calculus than afterwards. Clean it up first. Now, how many rules you got memorized? 6 of them. In these rules, do you see a product rule? No. Do you see a quotient rule? No. Do you see a chain rule? No. We only got these basic 6 rules. So when you got a product or a quotient or a chain type of problem, what you're going to have to do first is clean them up. So when you have a product, full it out. When you got a quotient, take your term and divide it out. Okay? When you got a chain rule, 3x plus 2 squared, fold it out. 3x plus 2 times 3x plus 2, fold that thing out. Multiply it out. Because you only got these rules to deal with. So look at this next one. I've got the integral of negative 5x to the 4th minus 7x cubed minus 2, all divided by x to the 4th dx. Now this is a quotient, but there's no quotient rule for integration. So what you're going to do is you're going to clean it up. You will notice in this problem, you're dividing by a single denominator, single term, x to the 4th. So to clean this guy up, this will become the integral, and you take that single denominator and put it under each term in the numerator. That gives you negative 5x to the 4th over x to the 4th, minus 7x cubed over x to the 4th, minus 2 over x to the 4th dx. Does that make sense? And clean them up. Now, what's x to the 4th divided by x to the 4th on that first term? They cancel, and you're left with just the integral of negative 5. With me? Minus 7's a constant, leave it alone. What is x cubed divided by x to the 4th? You've got a lot of canceling going on here. X cubed divided by x to the 4th leaves you with what? Well, x to the negative 1, or better yet, just 1 over x. That'll be times 1 over x. Does that make sense? And the reason why I'm leaving as 1 over x is that's a rule we have memorized. Okay? Minus, now this guy's got a power. When I got a power, I don't like powers on the bottom. I'm going to bring them to the top and make that exponent negative. So minus 2x divided by x to the 4th, that'll give you minus 2 times x to the negative 4 dx. Now, again, my goal is to start getting you guys faster and faster and faster in the ability to do antiderivatives or integrals. So when I'm integrating terms are being added, subtracted, I'm going to integrate each one. There's no reason for me to rewrite the integral and pull the constant out. I can do that all in my head. So here we go. This will be equal to, what is the integral of negative 5 with respect to x? Negative 5 times x. Integral of a constant is a constant times x. Minus 7 is a constant. That holds over. What's the integral of 1 over x again? Natural log absolute value of x. Minus 2 is a constant. It holds over. What's the integral of x to the negative 4? Add 1. What do you get? X to the negative 3 over negative 3. And then we put 1 big plus c for my constant integration. Does that make sense? I integrated each one of these guys, but I didn't go and did it the long way and write out the integral of each one. Once I've got it, once I'm adding or subtracting, I'm going to integrate each one. Now, the last thing you've got to do is more algebra. Clean up your answer to make it look good. So this is equal to negative 5x minus 7 natural log absolute value of x. A negative divided by a negative is a what? Positive 2/3. X to the negative 3, a negative exponent, if you want to clean them up, goes back where he came from, which is back to the denominator, and becomes a positive exponent. So that's 2 divided by 3x cubed, and then your plus c, and there is my solution. Does that make sense? Clean it up first. You only got six rules to actually, so you're going to have to turn any problem we got into one of these 6 rules, and that means a lot of algebra. Take a look at this guy. The integral of negative 7x to the 9th minus 6 over x plus 5 divided by x to the 7th. Before I integrate, I'm going to clean them up. Well, negative 7x to the 9th, that one's good. I can integrate that guy. Constant hold over, add 1 over, add 1. Minus 6 over x, that guy's good. Minus 6 is a constant, so the function's actually just 1 over x. I can integrate that guy. But you see that plus 5 over x to the 7th? I don't like x's to powers in the denominator. Anytime I've got an x to an actual power in the denominator, I'm going to bring them to the numerator. So it'll be plus 5x and make the exponent negative. X to the negative 7 dx. Now, that classic rule of when I'm integrating terms of being added or subtracted, I'm going to integrate each one. Constants hold over, so I'll just leave those constants out front. So integrating negative 7x to the 9th, negative 7 holds over. And integrate x to a power, you add 1 over, add 1. That'll give you integral x to the 9th is x to the 10th over 10. Minus 6 is a constant, so when you held over the 6, this is 1 over x. That's a special rule. Integral 1 over x is the natural log absolute value of x. Plus 5 is a constant. It holds over. And I got x to a power. X to the n, you add 1 over, add 1. X to the n plus 1 over n plus 1. Negative 7 plus 1 is what? Very good. X to the negative 6 over negative 6. And 1 big plus c. And then the last thing we're going to do is clean up our answer. So the answer is going to be negative 7 x to the 10th divided by 10 minus 6 natural log absolute value of x. Positive divided by a negative is going to be a negative 5 divided by 6. X to the negative 6, then x to the negative exponent goes into the bottom. That gives you 5 over 6x to the 6 plus c. There's my solution. Does that make sense? Look at the next one. I got the integral of 5 times t to the 2/5 minus 2 over t minus the square root of 5 dt. Okay? Well, this one's kind of nice, but the only thing they did was they switched all the variables. Now we got t's instead of x's. It's fine. So, we integrate each one of these guys. 5 is a constant. It holds over. What's the integral of t to the 2/5? Well, got to mentally add 1. Adding 1 to the 2/5 gives you what? 1 plus 2/5 is? 2/5 is plus 1. 1 is 5/5. 2/5 plus 5/5 is? 7/5. That would be t to the 7/5 divided by 7/5. Add 1 over, add 1. Minus 2 is a constant. What's the integral of 1 over t dt? Integral 1 over x dx is natural log absolute value of x. So this is going to be natural log absolute value of t. Here's a trick one right here. What is the integral of the square root of 5? The square root of 5 is nothing but a number. Square root of 5 is 2.23606. The derivative of square root of 5 would be 0. But we're not doing derivatives, we're doing integrals. What's the integral of the square root of 5? It's a constant. And the rule is the integral of a constant is a constant times the variable. But our variable is not x. What's our variable? T. So what's the answer? Square root of 5t and then 1 big plus c. Does that make sense? And then, here we go. Clean it up. When you Divide by a fraction, we'll invert and multiply, so it'll be 5/7 times 5t to the 7/5 minus 2 natural absolute value of t minus the square root of 5t plus c. And then cleaning up this guy, 5 times 5 is 25 over 7, t to the 7/5 minus 2 natural log absolute value of t minus the square root of 5 times t plus c. There's my answer. Well, geez, Dr. Taylor, didn't you always tell me when I had a square root? I don't do square roots. A square root is a half a power. You're right. And when I got a square root of a variable, I'm gonna take that variable and raise it to the 1/2 power. But square root of 5 is not a variable, it's a constant. So the square root of 5 is nothing but a crappy number. So who cares? He's just a number. When you integrate a number, you get a number times your variable. In this case, it's t. However, look at the next guy. And here's where John's fundamental rule of calculus plays a part. When you start doing these more advanced problems, first rule is clean it up first. Okay? So, this will become the integral of -3 times the 5th root of x minus 4 times the square root of x. Now you're taking the 5th root and the square root of a variable. I don't do radicals. Radicals, square root, it becomes a 1/2 power. An nth root of x is x to the 1/n power, right? So this will turn into -3x to the what? What's the 5th root of x also known as? X to the 1/5 power. Minus 4x to the square root of x is to the 1/2 power dx. Now, integrate. Integrating stuff that are being added or subtracted, you integrate each term. And constants hold over. So hold your -3. What's the integral x to the 1/5? Add 1 over add 1. 1/5 plus 1 is 6/5 over 6/5. Minus 4 is a constant, hold over. What's the integral x to the 1/2? Add 1 to 1/2, you get x to the 3/2 over 3/2 plus c. But now, instead of leaving it in this form, which is a correct answer, don't get me wrong, but we hate dividing by a fraction. So when you divide by a fraction, you invert and multiply. So this gives you, invert and multiply, 6/5 times a -3x to the 6/5. Excuse me, when you flip it up, it becomes 5/6. Make sure I do it right. 5/6, when you invert and multiply, times -3x to the 6/5. Minus, inverting it, that gives you 2/3 times 4x to the 3/2 plus c. And just clean up your constants. Now this is 5/6. 3 goes in the 6 2 times. Positive times a negative is a negative. That'll be -5/2 x to the 6/5. Minus 2 times 4 is 8 over 3, because nothing canceled there. X to the 3/2 plus c. There's my answer. Cleaning up your variables. And again, when you divide by a fraction, you invert and multiply. So this becomes 5/6. And so I was just cleaning up. 3 goes in 6 2 times. That's where the 2 came on the bottom. Take a look at the next guy. The integral of x cubed times 5x plus 6. We do not have a product rule for integration. But what you do have is algebra. Clean them up first. Before I integrate, I'm going to distribute my x cubed. This will give you integral of, what's x cubed times 5x? Very good, 5x to the 4th. Plus, what's x cubed times 6? 6x cubed dx. Clean them up first. Then integrate them. 5 is a constant, it holds over. Integral x to the 4th is add 1 over add 1, that'll get x to the 5th over 5. Plus 6 is a constant, it holds over. The integral x cubed, add 1, gives you x to the 4th over 4. One big plus c. Now clean up your fractions. The 5's cancel. I get x to the 5th. Plus 6/4, you can reduce that fraction by a factor of 2. 6/4 is the same thing as 3/2, x to the 4th plus c, and there's my result. All right. Does that make sense? Did I lose you guys anywhere on that? Okay. Here we have a little bit of a typo when they're on notes here, so I'm going to fix this for you guys. So this is typo. This is supposed to be a little f. Okay. All right. So it goes back to that notation. So this is a little f. Find the antiderivative of big F of x that satisfies the given condition that little f of x is equal to 4x squared plus 5 e to the x. And they gave you something else. Big F of 0 equals negative 2. This is this notation that, remember we mentioned that when I integrate little f of x dx, what do I get? Big F of x plus c. We're trying to use this notation. Does that make sense? So, directly at you guys, you want to integrate or take the antiderivative of little f so you can figure out what big F is. Does that make sense? So the answer to the question is, to get big F of x, we're going to integrate little f of x dx. So this would be the integral of 4x squared plus 5 e to the x dx. So big F of x is going to be equal to, well, 4 is a constant, leave it alone. What's the integral of x squared? Add 1 over add 1, what do you get? X cubed over 3. Plus 5 is a constant, leave it alone. 5. What's the integral of e to the x? E to the x, and then 1 big plus c for your constant integration. So we got the answer, and here it is, and it's already been cleaned up, but there's a problem. They have to tell you one other piece of the puzzle so you can figure out exactly what that constant is. That's what this is called. In terms of what we call differential equations, this is called the initial condition. This is the condition so you can figure out what the C is. So I'm going to use that. Knowing that big F of 0 equals negative 2, here's my big F. So big F of 0 would be equal to 4 times 0 cubed over 3 plus 5 e to the 0 plus c, but that's got to be equal to, they gave me big F of 0 equals negative 2. So I took my antiderivative and I plugged in 0 for all the x's, and I set it equal to negative 2. And the purpose of this is solve for it. It's all for the c, the plus c. What's 0 cubed divided by 3 times 4? 0. 0 cubed is pretty much 0. But here's the one. What's e to the 0? What's anything to the 0 power? 1. So this gives you 5 plus c equals negative 2. I'm going to subtract 5 from both sides. And that tells me c equals minus 2 minus 5 is minus 7. 3 dots in a triangular fashion means therefore big F of x is equal to 4x cubed divided by 3 plus 5 e to the x plus c, but c is negative 7, plus negative 7 is minus 7. And this is my answer. I just plugged in for c, the negative 7. Does that make sense? This initial condition is just used to figure out what the plus c is, so now you actually have the unique function for this problem. Does that make sense? All right? So how can they mess you up? Well, of course, when you throw word problems at you. The population of a town is growing at a rate given by dp over dt equals 216 minus 24t to the 1/2 people per year. The function to describe the population t years from now, if the present population is 9,200. All right? What did they give me? They gave me the derivative. It's 216 minus 24t to the 1/2 power. To get p back again, my population, I've got to integrate the derivative with respect to t. The antiderivative of the derivative. They're giving me the derivative. They put in Leibniz notation. So this would be the integral of 216 minus 24t to the 1/2 dt. So integrate. The integral of 216 with respect to t is 216t minus 24 is a constant. What's the integral of t to the 1/2? Add 1. That'll be t to the, adding 1 to, let's see, 24 there, sorry. 24t to the 1/2. You add 1, that'll be t to the 3/2 over 3/2. And one big plus c. So I'm going to clean this up. This is 216t minus 24t to the 3/2 times 2/3. Let's clean that up. Let's see there. But 3 goes in 24 how many times? 8. And 8 times 2 is 16. So P of t is going to be equal to 216t minus 8 times 2 is 16. T to the 3/2 plus c. But they wanted the original equation. There's another little piece of the puzzle they gave you, and it's right here. If the present population is 9,200, that means the population at time equals 0 is 9,200. That initial condition, the present population is 9,200, is used to find what C is. So here we go. Plug it in. P of 0 equals 216 times 0 minus 16 times 0 to the 3/2 plus c, and that's got to be equal to 9,200. Well, 0 times anybody is 0. 0 to any power is 0 plus c makes c equal to 9,200. So therefore, you get your answer. P of t is equal to 216t minus 16 to the 3/2 plus 9,200. There is my answer. So similarly, take a look at this last problem. What does marginal mean to you guys? Derivative. So the marginal revenue in selling X cameras is, so marginal would be my derivative, R prime, R being revenue, of X is equal to 189 minus 0.06X. Dollars per camera. Find the revenue, and hint, they're giving you the initial condition. If you sold no cameras, how much revenue did you bring into your company? No dollars. Okay, so big R of 0 equals 0. So to get the revenue, you're going to have to integrate the marginal revenue function with respect to X. This will be the integral of 189 minus 0.06X dx. So my revenue equation is going to be integral of 189 with respect to X, a constant times dx is 189 times X, minus the integral of 0.06X is going to be 0.06X, add 1 squared over 2, and one big plus c there. And just cleaning it up, what is 0.06 divided by 2? 0.03. So your revenue equation is going to be 189x minus 0.03x squared plus c. And since R of 0 equals 189 times 0 minus 0.03 times 0 squared plus c, and that's equal to 0, that's 0 and that's 0, so c equals 0, means my revenue equation, R of x, is going to be 189 times x minus 0.03x squared, and the plus c was actually 0. There is my revenue equation. So now, from that problem right there, you begin to see the power of the antiderivative and how important this integral is going to be important. We're going to give you marginal revenue, marginal cost, marginal profit, and you're going to go back and give me the profit, the cost, and the revenue equations. So study hard on this one, and we'll pick up something called U substitution techniques next time.